In this video, we are going to discuss how to analyze research question number 7, 8, and 9. In other words, how to test hypothesis 7, 8, and 9. To test such a hypothesis, we have to do what you call a chi-square test for no association or chi-square test for independence. So the analysis for such a research question is numbered 33. And here is an example. That's for the null hypothesis number 7 and the alternative hypothesis number 7. Chi-square test for independence or for no association. So here is a YouTube video, but I'm making an updated one specifically for this example. So what you do, you click on the link for the online calculator. It will take you to the chi-square test calculator. The website name is Statistics Kingdom, and it's a goodness of fit test of independence, or McNamara test. So you scroll down and you tell the calculator which goodness of fit you would like, and it's a test for independence or association. The significance level can remain at 0.05, and all the rest can remain the same. Now we are going to enter the data, the raw data directly. Okay, so the raw data can be your own, or if you encounter difficulties obtaining data, you can use my own. My data is available in Class 365 in Google Classroom, sorry, CI3QYBO. You go to classwork and you go down to project. Grell's example of research project. And here you can find my data, Grell data research project. So when you click on this, you'll get my spreadsheet with my data on it. Now, to use this calculator, you have to create the contingency table. So the raw variables, we can call it gender, male and female. So gender versus math attitude. Because as you can see, the research question is asking, is there an association between gender and attitude towards maths? So the two variables there are gender and attitude, or math attitudes. So we can name the row variable. Okay, just a minute. Let's see what that was. Okay, I see they have there. Let me click on the link again because I just noticed something there. Let's do that again, independence. And let's go there. Also, variable B will be coming in the row and variable A coming here. Okay, now I notice. So if I put this as gender, then I can put this as male and female, and variable A will be attitude. Now the attitude now comes in 3 categories: do not like, neutral, and like. Okay, so we can abbreviate do not like DNL, neutral N, and we can insert a row for like L. Okay, or you can write the word, it does not really matter. Right. Now we've got to count to create the contingency table because these values inside here will be the frequency, how many males that do not like. So male and do not like, female and do not like, male and neutral, female and neutral, and so forth and so forth. Okay, so we go to the table. If you want, you can copy these two columns. Add another spreadsheet and paste it separately because you might want to modify it and keep the original information without having altered it. Okay. So, and you can call this chi-square. You can rename this chi-square. Okay, as you wish. Now, the first risk values we have there is male and do not like. So let's call a code to indicate that we have dealt with that. So male and neutral, sorry. So male and neutral, we have one already. Male and neutral, one. Okay. Let's go back. Female and do not like. We can just call a code just to indicate. Female and do not like, we've got one. Female and do not like. So we have another one there. Right, let's go back again. Male and neutral. No, female and neutral, sorry. Female and neutral. Female and neutral. Female and neutral. We've got one there. Then we have another male and neutral. So that will be two males and neutral. So we just upgrade this to two now. Okay. So by now you should get the idea. Female and like. Female and like. Female and like. That's the first female and like. Female and neutral. Do we have a female and neutral already? Female and neutral, so that will be the second female and neutral that will operate to number two. Female and like. Female and like. Do we have a female and like? Yes, so that's the second female and like. And you do this for all the respondents. There's another female and neutral. So you'll get the idea. Okay? That's a third female and neutral. Okay, so I'm going to continue till when I get all and to proceed. So I'm going to pause the video, continue, and come and to pull up the cells, the remaining cell. So I've reached up to 17 and I have a female and like, and it appears as the first female and like, a male and like, sorry. Male and like, so that's the first male and like. And here all my cells have a number in it, okay? But you've got to continue doing this till when you, okay? So all 41. Or all 40 because the first row is the title. Okay? Now what you do now is just click calculate. And the calculations are shown, and here are the results. Okay, so according to, remember I did not put all the data, so this is not the exact accurate results. That's just the results based on what I've put so far. It says since the p-value is greater than alpha, HO is accepted. The statistical model fits the observation. There is not enough evidence to suggest an association between variable A and variable B, because that is what the null is saying. The null is saying that there is no association. Okay, and it appears that based on the data I have inputted already, that the p-value is greater than the significance level. And once the p-value is greater than the significance level, we know that we have to accept the null hypothesis based on the p-value approach. We should be able to recognize this document. We used it in the classroom, and it gives you a brief summary of the steps of the critical value approach and the p-value approach. So when it comes to decision criteria for the p-value approach, you reject the null if the p-value is less than the significance level of alpha of 0.05. Otherwise, you do not reject the null. So if the p-value is greater than alpha, then you do not reject the null. And we can clearly see here that the p-value was greater than the significance level, so the null was not rejected. And if you go further down now, it will actually give you the value of the p-value. The p-value equals to 0.4185. So the calculator will calculate the p-value for you, okay, and give you some extra information. And 0.4185 is greater than 0.05. So in a nutshell, that the null is not rejected. And it means that the chance of type 1 error rejecting a correct HO is too high, okay? And the larger the p-value, the more it supports the null hypothesis. All right, so what you can do, you can copy this as your results. Okay, you don't really need here you have the chi-square test statistic, okay? And if you are doing a critical value approach, you can use that, but we are doing a p-value approach. So this, you can copy this, okay, or you can screenshot it and you can paste it in your working, or type it out, okay? And that will be your analysis. But remember, since I did not input all data, chances are the p-value might be less than the significance level, okay? And surely it will be different than 0.4185, okay? So I think this should help to clarify how to perform a chi-square test for no association using an online calculator and the data that you have collected, or you can use my data. And that will be for analysis number 33 and 34 and 35. They are all chi-square tests for independence or no association.